Use the following probability distribution to answer the following questions. Calculate the mean, variance, and standard deviation of the distribution. You may round your answers to 2 decimal places if necessary. In order to calculate the mean, variance, and standard deviation, we just need to take into consideration that we have grouped data. And anytime we have grouped data, when we use our OneVarStats program in the calculator, we have to make sure we add onto it the L1, L2 parameters so that the calculator knows that we're doing weighted statistics. The value of the random variable is always what you put in L1, and your probabilities is what you will put in L2. It's okay that the probabilities are decimal values instead of integers, and calculator will be fine with that as long as you don't use any negative numbers for the probabilities. Now, if you have any information in your lists already, remember just highlight the name of the list, press clear and enter, and then start entering into L1 the different values of your random variable x, and into L2 put the different values of your probabilities. Once you're done, call up the function OneVarStats, taking care to give it the inputs of L1, L2 so that it knows to use weighted statistics. And the mean of the distribution, the only thing that were reported is a sample mean, but the calculation between the sample and the population mean is the same. So it's okay to just use that as your answer, 7.3. The variance we'll get in a moment. The calculator doesn't give you the variance by default, but it does give you the standard deviation, so we'll answer that to 2 decimals, which would be 3.72. Notice that there is no sample standard deviation given, and the problem is that the sum of our probabilities add up to 1. Now, for the variance, what we need to do is we need to take the standard deviation and square it. Now, when you square a number, it's actually very sensitive to how much you round. And the homework should be able to give you credit regardless of how you treat the rounding when you go in and square the standard deviation. But if you want to make sure you're getting the most accurate answer you can, one thing that you can do is if you press the vars key, that stands for variables. And variables is the location in memory where information is stored. And when you run OneVarStats, all of that information is stored in variables related to statistics. So you can actually call up your population standard deviation and hit square, and it will take the entire value that was on screen up to, I think, 10 or 12 decimal places and square that number, making sure you have the most accurate answer you could possibly get. So 13.81. To compare, if you took 3.72 and you squared that number, you get 13.84, which is not much different, but it could be the difference between the computer marking your answer wrong and your computer marking your answer right. So to be safe, use as many decimal values as you can in the calculation, and then round your final answer. The last question asks, what is the expected value of this distribution? Well, one thing that you should understand is expected value, oops, don't need a sigma there, but an E. Expected value is just an interpretation of the mean of the distribution. So we're really just looking for the value of the mean. So in this case, the expected value is just 7.3. So the mean is the most likely thing to occur for a set of data. So if you're expecting something to happen, then the thing that would most likely happen is the mean. That's what you expect to occur. So that's how you interpret that.